Namaste. Welcome back to the next chapter of organic chemistry, hydrocarbon. I told you in the previous video, so many connections were there between the chapters of organic chemistry. So you establish that connection in your mind. Then you can answer any type of the questions from organic. Directly entering to the chapter. First question, suitable method for the preparation of methane. Options, catalytic hydrogenation of unsaturated hydrocarbon. See, unsaturation means double bond or triple bond. So that should contain at least 2 carbon. So from a 2 carbon hydrocarbon you cannot prepare methane by hydrogenation. So that is not a method. Coal-based electrolysis also, the first member that you can prepare by coal-based electrolysis is ethane. Third method, Wood's reaction also you can prepare effectively a 2 carbon member. And the last one is decarboxylation of sodium acetate with the soda lime. That is answer. Soda lime, decarboxylation of sodium acetate, CS3CONA. And when we are treating with the soda lime means NaOH and calcium oxide. Okay. A molecule of Na2CO3 is detached. So the molecule formed is CH4. So that is the answer. Option number 4. Question number 2, which of the following has highest boiling point? Remember, straight chain hydrocarbons have higher boiling point compared to branches. That is a simple idea. And one more point connected to the same thing, branching increases the tendency to dissolve, solubility. So branching decreases the boiling point but increases the solubility. That is a concept. So here normal hexane 2-methyl pentane is actually hexane, 2,2-dimethyl butane, that is also hexane, 2,2-dimethyl butane, sorry, 2,3 and 2,2. So all 4 options are hexane. So among these hexanes, straight chain is having highest boiling point means normal hexane. Okay, isopropyl bromide by Wood's reaction. What is Wood's reaction? You know what is Wood's reaction? So whenever you are learning Wood's reaction, study in this pattern. Rx gives Rr. Actually Rx plus 2Na plus Xr gives, in presence of metallic sodium, ether. Ether is a condition. 2NaX is detaching, Rr is a production. So short form of Wood's reaction, Rx, Na, ether, Rr. Study in this pattern. Normally I am explaining in the class, this is the pattern. Rx gives Rr. Agree? Rx gives Rr. Actually Rx 2 moles are required. Okay, that keep in mind only. So in this particular question, isopropyl bromide. What is isopropyl bromide? Isopropyl bromide. CS3, CH, CS3. This is called isopropyl group. And here I am placing a bromine. So when we are treating with the Na and ether, so make it double. So what is the compound? CS3, CH, CS3, again CH, CS3, CS3. So 2,3-dimethyl butane is the compound. 2,3-dimethyl butane is the compound. Okay, remember 2,3-dimethyl butane. Option is the number 4. Agree? Question number 4. Hydrogenation of but to YNE in presence of Lindlar catalyst. Lindlar catalyst, you know, palladium carbon. You know, palladium is an active catalyst, but in presence of graphite, carbon, its activity is suppressed. So carbon is actually acting as, technically called as poison, catalytic poison. Okay, the compound originally taken 2-butane. What is 2-butane? CS3, C triple bond C CS3. I am giving 2 reactions. One is Lindlar catalyst. What is it? Palladium carbon. Next is sodium plus liquid ammonia. Sodium or lithium plus liquid ammonia medium. See, only 1 pi bond is broken down. Lindlar catalyst is palladium plus carbon. So in presence of carbon, activity of palladium is decreased. So the problem, it cannot break all the pi bonds of the triple bond. It can break only 1 pi bond. So effectively you are going to get a alkene. Here also the same thing happened, but there is a difference in the stereochemistry. I will give the product. This is the product here and this is the product here. See the difference? Linear catalyst promotes cis hydrogenation, whereas sodium plus liquid ammonia promote trans hydrogenation. Okay, what idea? Cis hydrogenation. Linear catalyst promote cis hydrogenation. So remember that. Agree. Question number 5. Propene can be obtained from 1,2-dibromopropane by the treatment of propene from 1,2-dibromopropane. 1,2-dibromopropane. What is it? 1,2-dibromopropane. This is a compound. One 2-dibromopropane you are converting to propene means this is the molecule. So actually you have to remove 2 bromine atom. So removal of bromine means dehalogenation. And what is the dehalogenation reagent here? It is nothing but zinc. Okay, zinc is a dehalogenating agent. Alcoholic KOH is dehydrohalogenating agent. Aqueous KOH is that is used for substitution only. Question number 6. Identify the product X in the following reaction. Propane 2-ol sulfuric acid, that is in the arrow mark, H2O plus X. You know, sulfuric acid is a dehydrating agent. Propanol, when dehydrated, you are getting propene. So answer is propene. Okay. There is a mechanism also for the reaction. I will give the mechanism. Can you see what are happening behind the dehydration of propanol? CH3, CH2, CH2OH. There is a lone pair. Sulfuric acid gives an H plus ion. So by giving the lone pair, it is absorbing H plus, so that it is forming an oxonium ion. CH3, CH2, CH2, OH2 plus, isn't it? Okay. So this OH2 plus is removed as water. This electron is, okay, bond is shifted here. So that you are getting a cation, CH3, CH2, CH2 plus. Agree? That is a primary cation, primary carbocation. So actually there is a rearrangement happen. And then only it will undergo the next step. Okay. After removing this OH2, you are getting a positive charge, and this positive site will be shifted here. That is happening inside the reaction mechanism. Whenever a carbocation is formed, it will try to rearrange to the maximum stable form. Compared to primary, secondary is more stable. Okay, compared to secondary, tertiary is more stable. So if there is an option for the rearrangement, it will do. Agree? Here, this positive charge shifted here means this hydrogen is absorbed as H minus, hydride is shifted. So this is the stable intermediate formed in the dehydration of propanol. And finally, it will release NH plus from the beta carbon with respect to the positive carbon. These two positions are exactly equivalent, so no problem. Suppose this carbon releases NH plus, here there is a chance for forming negative, and that negative and positive join together to form alkene. So that is the method of formation of propane from propanol. This is the mechanism. Okay. Next one. Addition of hydrogen halide to unsymmetrical alkene follows Markovnikov's rule. I think you know what is Markovnikov's rule. Compound formed when butadiene react with an acidified solution of KMnO4. Butadiene. Acidified KMnO4 is a stronger oxidizing agent. Butadiene. What is butadiene? CH3, CH double bond, CH single bond, CH3. I am giving two reactions, one with alkaline KMnO4, cold dilute alkaline KMnO4 and acid KMnO4. Okay, we can distinguish these two by its action. This is a mild oxidizing agent and this is powerful. That's all. Mild dilute alkaline KMnO4, common name is called Bayer's reagent. Bayer's test also you know. This reagent helps the carboxylation. Okay, not carboxylation, hydroxylation. Oxidation is happening, but oxygen is adding in the form of OH group. This pi bond is broken down. Okay, so that two valencies are creating, and that valencies are joined with OH group. So here the product formed is CH3, CHOH, CHOH, CH3. But here KMNO for strong oxidation condition, this double bond is totally broken down. Okay, there are two options. There is a chance for the formation of a carboxylic acid as well as a ketone. Carboxylic acid is formed from the double bonded carbon containing hydrogen. Suppose double bonded carbon, there is no hydrogen, it will form a ketone. But in this particular molecule, double bonded, both of the double bonded carbon atoms have hydrogen. Both of the double bonded carbon atoms have hydrogen. So that is turning to carboxylic acid only. So here the product is 2 molecules of acetic acid. Okay. So your answer is acetic acid, CH3COH, option 1. Agree. Then question number 9. An alkene which gives only acetone on ozonolysis. That means you are getting 2 units of acetone. You know how to produce the original alkene from the ozonolysis product. What is acetone? CH3, C double bond or CH3, this is acetone. Again I am writing one more acetone molecule and you simply remove the oxygen, that's all. Join them. This is not a reaction, this is for our convenience we are writing. So this is the structure of the original alkene. So 1, 2, 3, 4, 2, 3 dimethyl 2 butene is answer. 2, 3 dimethyl buta-2-ene, answer option 4. Question number 10. Which of the following will exhibit a cis-trans isomerism? See, cis-trans isomerism propene cannot show. 1 phenyl, 1 propene, 1 can show. 1 phenyl, prop 1-ene. What is 1 phenyl, prop 1-ene? CH3, CH double bond, CH, C6H5. So when these two hydrogen atoms are on the same side, it is called a cis. If it is opposite, that is called a trans. So that molecule can show cis-trans isomerism. Okay, 2-methyl pent-2-ene cannot show. 2-methyl pent-2-ene, what is 2-methyl? 2-methyl pent-2-ene. This is 2-methyl pent-2-ene. Okay, across the double bond, there is not a same pair of hydrogen or same type of group. Yes. Here there are 2 methyl group. Here there is only 1 H and 1 ethyl group. So how can you distinguish cis and trans here? Not possible. Okay, so 2 methyl buta-2-ene is not possible. 2 methyl pent-2-ene. Next 2, 3 dimethyl buta-2-ene. Never. This is 2, 3 dimethyl buta-2-ene. No chance for cis-trans isomerism. So option we have discussed as option 2. Next, CH3CH2Br, CH2Br single bond CH2Br plus KOH. Alcoholic, medium alcoholic. So alcoholic KOH dehydrohalogenation, you are getting X. Again NaNH2, another dehydrohalogenating agent. There is a difference between alcoholic KOH and NaNH2. Alcoholic KOH and NaNH2 both are used for dehydrohalogenation, but double bond formation is more promoted by alcoholic KOH. Triple bond formation is more promoted by NaNH2. Okay, both the reagents are used for the same purpose. Anyway, there is a selection. Single bond can be transferred to double bond by better reagent alcoholic KOH. Double bond can be transferred to triple bond by NaNH2. So the reaction I am writing here, CH2Br, single bond CH2Br. When I am treating with the alcoholic KOH, a molecule of HBr is removed. If Br from here, then H from here, beta elimination. Otherwise in this pattern. So I am writing in this pattern. So the product is CH2 double bond CHBr. This is the first compound formed, and again treated with the NaNH2 means again one more molecule of HBr is removed. So the product is CH triple bond CH. Okay. So the question, what is the last product? CH triple bond CH is the product. Okay. Dehydrohalogenation. This is exactly given in NCERT. Question number 12. Hydrolysis of calcium carbide, production of acetylene, CaC2 plus 2H2O gives COH twice plus C2H2, acetylene production. Acetylene means ethyne. Acetylene is the answer given. Correct decreasing order of acidic strength. Triple bonded carbon containing hydrogen is more acidic. Why? Because triple bonded carbon is sp hybrid with a 50% S character. As H character increases, electronegativity increases, so it will attract a shared pair from hydrogen, so H is removed as H plus. So compared to triple bond, the next position goes to double bond, alkene, then to single bond. So order is crystal clear. Decreasing order of acidity, acetylene, ethene and ethane. Option number 1 is the correct one. Then propyne is treated with a solution of bromine in CCl4, red color is discharged. Propyne, definitely. And saturation can be tested by adding bromine in CCl4. This is due to the formation of propyne contain 2 pi bond. In triple bond, 1 is single bond and other 2 are pi bond. So all the pi bonds are broken down. So you have to add 4 bromine. Okay, so 1122 tetrabromo-propyne is answer. Propyne, what is propyne? CH3, C triple bond CH, and you are adding bromine means this pi bond is broken down, this pi bond is also broken down. So 4 bromine atoms are added. So you are getting 1122 tetrabromo-propyne. That is answer. Hydration of propyne in presence of HgSO4, H2SO4. Propyne, the same compound. There is a special name for that reaction. Do you remember? Hydration of alkyne in presence of Hg2 plus. Anyway, CH3, C triple bond CH, Hg2 plus H2SO4. Okay, dilute sulfuric acid means it contains water. So first a pi bond is broken down and HOH are distributed. So you are getting CH3, C, OH, double bond CH2. This is the first form obtained. It's an enol. Double bond enol. So it undergo exchange of pi bond and hydrogen, tautomerization. So this becomes CH3, C double bond O, and this becomes CH3. So acetone or propanone is the product formed when we are hydrating propyne in presence of Hg2 plus H2SO4. Acetone is answer. Option 3. Question number 16. Propene and propyne can be easily distinguished. One is an alkene and other is an alkyne. So KMnO4, dilute KMnO4, Bayes reagent, bromine water, etc. cannot be used because both of them give. So answer, ammoniacal cuprous chloride and ammoniacal silver nitrate, because it will react only with alkyne with the terminal hydrogen, terminal triple bond. Suppose the triple bond is terminal, then only it can connect with the hydrogen. Such alkyne will react with the ammoniacal silver nitrate and ammoniacal cuprous chloride. If it is ammoniacal silver nitrate, you are getting a white precipitate. If it is ammoniacal cuprous chloride, you are getting a red precipitate. So option 4 is correct, B and C. Cyclic polymerization of acetylene produces. Acetylene on trimerization, you are getting benzene. Tetramerization, cyclooctatetraene, like that. So the answer, benzene is there. Trimerization is the better word used. Okay, from acetylene you are getting benzene. That is exactly given in NCERT. Electrophile involves the nitration of benzene. You know what is the attacking species of nitration of benzene? NO2 plus. HNO3, H2SO4 when joined together, you are generating an electrophile, that is NO2 plus. That NO2 plus is attacking benzene, forming a carbocation, and that is stabilized through resonance and finally detaching H plus. NO2 plus. Next 19th question, benzene plus 6 chlorine anhydrous AlCl3 dark. Anhydrous AlCl3 dark. Okay, what is the product formula? Do you remember that reaction? In presence of Levy. Question number 19, benzene plus 6 chlorine AlCl3 dark. What is the product? I will write 2 reactions. You study it as a comparison. Benzene, 1 chlorine in presence of light, HNO. Another chlorine in presence of AlCl3. And I am taking excess of chlorine. Okay. If it is chlorine light, all the pi bonds are broken down and you are getting Cl, 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 and here double bonds are remaining intact, but since excess chlorine is present, all the corners are substituted by chlorine. So this is your question. This is called hexachlorobenzene. This is called benzene hexachloride, BHC. Okay, so find the proper option. Agree? Question number 20. Which of the following constituent of meta-directing in electrophilic substitution reaction of benzene? You know, plus M and minus M group we have discussed in the previous section. All plus M groups are orthopara directors, all minus M groups are meta directors. Okay, why? Because when a plus M group is present, what is the role of plus M group? You know, it is participating in resonance by giving electron. So automatically while writing the resonating structures, ortho and para corners become electron rich. Benzene normally undergo electrophilic substitution. Agree. So incoming electrophiles mostly goes to ortho and para. That is why plus M groups ortho para directors. When a minus M group is connected to benzene ring, it will participate in resonance by taking electron. So when it is taking electron, ortho and para corners become positively charged. So it is not possible to attack a positive electrophile to ortho and para. So the probable attack happens at the meta position. So find a meta director means find a minus M group. CS3 is there, OH is there, NH2 is there, CHO is there. Find the answer by using your knowledge. So these are the 20 questions from the chapter hydrocarbon. Okay, study it thoroughly. Okay, don't hesitate. The next we will go to second year chapters, solid state, solution, electrochemistry, kinetics, like that. So these are the two sections of organic chemistry. Study it thoroughly. Okay, I have given so many assignments for you. Okay, after finding the answer, tell me in group. Okay, that's all. Thank you.